Hello. This presentation is on CS 683 project checkpoint 1. Project title is Improving IPCP with Irregular Access Support using ISB. Team members are Arif Ali and Shomik Dotto. So we discussed this thing in our checkpoint 1. Problem statement is IPCP, a bucket of prefetcher. This cannot track irregular access pattern, like for example temporal locality. This below access pattern cannot be tracked by any prefetcher, which only tracks based on strides of regular access. These are type of access patterns are very much important for graph processing. Prior works done in this area is two papers. One is discussed 2020, that is bucket of instruction pointers. This is basically is a bucket of prefetchers. 4 prefetchers are integrated together. Another is that ISB prefetcher, which tracks irregular access pattern. Now what is our goal is to integrate this temporal stream prefetcher into the existing IPCP prefetcher. Moving ahead, so these are the work done in checkpoint 1. We integrated IPCP and ISB in ChamSim, and after that we tried with gap and SpecCPU benchmarks, but unfortunately we didn't find any speed up for gap. So after discussion we moved to SpecCPU benchmark only. So and the initial integration were done. So this was the result of initial integration of SpecCPU benchmarks, but here as it was in the initial state, we didn't get any significant speed ups. As we can see here in this, for GCC the IPCP ISB integration was very low than the normal IPCP prefetcher, and others, and we didn't get that much significant speed up. So we had to change the configuration bit. So the plan for checkpoint 2 was like this. We had to add the counter for confidence counter, and to add up the prefetch degree dynamically and share the IPCP tables, which we didn't do. That Arif will describe afterwards, and adjust the ISB parameters and refine the irregular class access. This is the most important part of our project, which we did in this checkpoint 2. So from here Arif will describe.
Yeah, so here what we did is actually we looked at the existing implementation, and we saw that what ISB does is it trains on the mist stream at L2. So we due to this type of different configurations, we checked multiple configurations, and so the work done here is we implemented we tried to test the confidence counter that it uses internally to map structural addresses, but we found that for influencing prefetch decision it is not that helpful, and also but the accuracy based prefetch degree adaptation that was already in IPCP, we did use that, and the ISB default degree is 6, and it is being changed based on the accuracy runtime. And also we tried to share the IPCP IP table with ISB to give the common metadata, but because IPCP uses a very small table and ISB keeps a per PC stream, the whole stream, so it is found to be actually hurting performance because it is not getting enough space to keep all the patterns. And also what we did is refined the classification logic for irregular access, which we will discuss now, that is the various configurations. And so these are the simulator configurations. So we have only tested on one core, and these are the TLB and 4 GB DRAM, and these are our cache hierarchy. And for the simulation we use 50 million warm up and 50 million simulation. So this is our a lot of work went into this to evaluate multiple configurations for IPCP ISB. We are calling it V2 because of the improved performance we are getting here. So we only took a subset of the benchmarks as discussed by sir. So here we took Soplex, Omnet, Zalank, GCC. So here actually that Soplex, Omnet and Zalank is prefetcher, traces where ISB actually performs better than IPCP. So we focused on that to evaluate our performance on that. And GCC is there which in which IPCP performs very good. So GCC is there to also measure how much IPCP performance we are getting inside our combined prefetcher. So out of this, if we look at the geomean, we are saying that if we let the ISB portion of the code to issue prefetch first before the others, other like global stream, IPStat or complex stat issues prefetch, then we find we are getting around 1.80 speed up over the baseline. And if we see the IPCP numbers, it is 1.56 on the geomean, and ISB is 1.57. Yeah. So it may change on the, if we take other spec CPU benchmarks, we will be doing that in the next checkpoint. So here are the existing the IPCP, the existing benchmarks, existing accuracy and coverage that is shown in this graph. And if we see the this is the existing combined prefetcher, this is V1, and this is the changed one, that is here we are gaining, in most of cases we are gaining accuracy. So and mostly we are gaining coverage a lot. In some cases like Omnet PP, we are losing both accuracy and coverage, which we will discuss why it is so. But in most cases we are gaining coverage. So yeah, this is the for V2. And finally, since we have found that ISB first configuration is the best, and so these are the same benchmark that are shown in the checkpoint 1. So here we are getting finally 1.63% speed up, 1.63 is time speed up, and on an average we are gaining 15% and 18% more speed over IPCP and ISB.
In most of the cases.
Yeah, in most cases we are gaining performance better than 2. So we are getting the best of the both worlds here in our combined prefetcher. So for the final submission, these are our plans. We can adjust this we didn't do in this checkpoint, that we had adjust the look ahead distance and buffer size and stream length actually to look for specifically Omnet if can improve performance on that. And also we have to evaluate the per class contribution in the combined prefetcher, that is like how ISB is contributing, how much GS and other classes are contributing. And further we can define classification logic by evaluating more configurations. There are a lot of configurations we can evaluate, and more spec CPU traces we will evaluate, and also we will discuss with sir to how more optimally we can design the prefetcher. Yeah, so we saw that mainly the main takeaways are performance in GCC is increased due to our proper incorporation. What happened actually was ISB, because it trained on the midstream, it had like a return statement, like if cache hit, it just doesn't activate the prefetcher. It was there in our version 1, so it was actually hurting performance. Only during the miss, the both IPCP and ISB combined prefetcher was getting activated, and it was not good enough for GCC. As we already saw in the benchmarks. And on Omnet we see that is able to reach the ISB performance specifically due to that how it is trained, that if we train on the midstream on ISB, it is actually gaining performance on Omnet, but for that the others benchmarks are actually hurting. So you have to decide some
which side we have to go.
Yeah, some middle ground for that.
Yeah.
So these are our GitHub link, and yeah, thank you.
Thank you.